Our next speaker is actually a repeat. He gave one of our longer talks in North America XConf 2021, and he's repeating that this year. For those of you who've been following what Martin Fowler has been releasing on martinfowler.com, there's a new series on scale ups, Series A, Series B, Series C startups, and early stage organizations that have gone on their journey into maybe a public offering. Ricky has been working at an organization within that space as they've been accelerating their scaling journey quite significantly. And what we've seen is that there's a lot of different styles and approaches that you might take in scale ups versus what you might take in enterprises that have a lot more process overhead, a lot more controls. And we are exploring that as an organization, as you can see in the series on martinfowler.com, one of which Ricky has contributed to, the most recent one. And you'll hear from Ricky right now on some of the lessons he's learned. So welcome to the stage.
Thanks, Brandon. Really appreciate it. As Brandon mentioned, my name is Ricky Zachary. I'm a tech principal here at ThoughtWorks. I've been working for ThoughtWorks for 1 year. In late June was my 1 year anniversary. I have about 16 years of total experience, and as Brandon mentioned, I've been working with one of our major digital scale-up accounts here at ThoughtWorks for the past year. And one thing that I've added to kind of my hobbies is this newfound love of deep sea fishing that I have. So please reach out to me on Twitter if you know of any awesome deep sea fishing spots in the US. So the agenda that I want to go forth with for the talk is, as Brandon mentioned, we've been dealing with a lot of these new digital scale-up accounts. We've been really helping them achieve massive amounts of growth. And for myself, for the past year, I've been working with one of these scale-up clients on a number of different issues and helping them to scale their organization, both from increasing the number of customers that they're able to provide products and services to, as well as producing those services within a very, very competitive marketplace, and then also scaling their technical and architectural components to deliver value for those end users. As I've worked with this scale-up account, I've noticed that there are some repeating patterns that we see on the architecture side. Those may accelerate growth, ease delivery of new production features, and help improve growth and deliver value. We've also seen some architectural anti-patterns form where those things have hindered growth and helped to prohibit delivery of value. During this talk, one of the things that I'm going to be looking at is defining, one, what are scale-ups? What are these things? What are these types of organizations? What do they look like? Outline some of the patterns that have been identified, and then discuss some of the measures that can be taken to show and value, deliver value, show progress within a very changing, competitive, and evolving landscape. And then we're going to look specifically at the architectural patterns and how those architectural patterns allow for those organizations to continue to grow more rapidly, to scale rapidly, and to continue to deliver new features, new products to their customers. One thing to mention is that these observations that we've been seeing, while they're not specific to scale-ups at all, and we've seen these types of observations across all different types of organizations that are producing software, we want to talk about these architectural practices within the context of scale-ups for two specific reasons. One, within scale-ups, these types of architectural patterns are exaggerated due to compressed timelines, due to highly competitive marketplaces. And then also, because of those compressed timelines, it's actually easier to see these patterns in action. The compressed timelines allow for experimentation to happen at a much faster timeline, and you're able to enact change within that confined context. So as we walk through these topics, we're going to look at the architectural patterns themselves, the anti-patterns, and then we're going to also look at some ways to measure improvement and what metrics we should be looking out for so that we can actually see these architectural patterns affect change within an organization. as I said, let's define what a digital scale up is. So we've been dealing with these types of organizations, and generally we'll talk about startups, right? Everyone talks about startups as different types of companies and organizations that are there, but digital scale-ups are a subclass of these types of startups. Startups within the phases that are here, within the swim lanes of each of these phases, startups generally are in the earlier phases, phase 1, phase 2. The digital scale-ups are primarily are in phase 3, organizations that are experiencing hyper growth. The organization that I work with and support experienced massive growth in the early 2021 timeframe, where they saw their user base increase by upwards of 4,000% almost overnight. So once you're moving from phase 1 into phase 2, and you start seeing that traction being gained, and you start seeing your user base increase exponentially, that's when you can start saying that you're a digital scale up and you're starting to see that hyper amount of growth, right? And again, characterized by seeing a high amount of change in both their user base. That's generally an increase in the user base and the number of users, but also an increase in demand from those users of new and innovative products to compete within the marketplace. And this fosters an increased need for experimentation and technical knowledge within those types of organizations. So as I mentioned, the organization and client that I support are within that phase 3 swim lane, and they're experiencing large amounts of growth within their user base and the adoption of their mobile platform. And while we've been working with this organization for the past year, we've been seeing that hyper growth means that there's been a large amount of change and flux in the architecture, and that generally precedes these different types of bottlenecks that would happen. So those bottlenecks are things that would prohibit the ability to really change and evolve the architecture and deliver technical capabilities to their users. And those can lead to massive disruptions in delivering all sorts of features, new products, new innovative solutions to their end users. So looking at these types of, looking at phase 3, that hypergrowth, and those types of bottlenecks, there's different types of activities that actually happen within there, and those bottlenecks can correlate to those different types of activities. So the types of activities that you would see are highlighted there in the phase 3 swim lane. And from an architectural standpoint, the important characteristic that we want to highlight here is that the architecture at this point within phase 3 needs to have mechanisms that will enable the customer to experience and move forward with that growth. Many times when we're in the earlier phases of a startup, we can actually do more rapid experimentation and we can have more architectural mistakes. But as we're leaving out of phase 1 and phase 2, we'll see that some of those architectural decisions cannot handle the scale of larger workloads, more diverse communication protocols, and that inhibits growth for particular organizations. However, the interesting thing in working with my client and their organization that we've seen is that sometimes more complex architectures that you would think would foster some of those the growth characteristics actually don't allow for rapid team expansion, splitting out concerns, and this can be due to a number of reasons. The primary reasons are around complexity and the addition of technical debt. And technical debt in particular is one of the leading causes of the inhibition and the ability for that company to not experience that growth. And we'll talk about identifying and eliminating some of those identifying and eliminating technical debt in some of those areas. But the one takeaway is that while many of these organizations are experiencing hypergrowth, they generally will make strategic decisions on how many shortcuts they need to take and where those shortcuts need to be taken, because many times there's a prioritization on delivering products and features, and that will almost always outweigh their ability to make the most perfect solution and to make the most architecturally sound decisions, right? The idea is that you have to make these decisions based on the knowledge and the information that you have at hand. So we talked about technical debt. The interesting thing is that if you're looking at an entire architecture via some sort of visualization tool, you can see where there are areas of technical debt. It's very easy to see those things when you're looking at it. But when you're talking to development teams, when you're talking to engineers on with a particular client or even a particular organization, you'll see that many times they think that their architecture is the most sound. It is the best architecture that's out there. So there are some other identification strategies that we would have to utilize. One is taking a team-based approach. If your teams are already organized and outlined by a particular service or a particular domain, it's very easy to start seeing how each one of those teams and the ownership of their business capabilities and how they're maybe deviating from certain standards or from certain common approaches, how that's going to introduce technical debt. So having a team or an organizational structure that allows you to organize different business capabilities and different products is a really easy and upfront way to start identifying where technical debt lies. The other one is to identify complexity in new products. One thing that my customer has been working on is new transactional scale, right? Being able to take in a lot more transactions at scale. So that could be identified as a new product. What are the complexities around identifying and bringing in new transactions? What does that look like? So additional complexity could be related to the amount, the scale of how many new transactions they're taking in, but it could also be the diverse types of different transactions, right? We can't repeat some of those same patterns over and over. If we have certain types of new shipments that are coming in, and those are completely different than the different types of transactions that have already been consumed, that level of complexity, both from a horizontal and domain perspective, as well as just the overall scale, is something that we would be looking to identify areas that could introduce new technical debt into the architecture. The other one is, the last strategy is to seek out slow production delivery areas. So areas where teams are struggling with delivering products into the customer, to the end users. Those are areas where there might not be architectural technical debt, but there will always be some level of technical debt there. And then you can start peeling that back and start looking and saying, are there underlying architectural issues related to our messaging protocols or how we're integrating with other products or how we're integrating with other services, and then start to figure out what does that technical debt look like and how do we either eliminate it or readdress it. And then thinking about eliminating technical debt, there are a couple of additional ways, but I wanted to highlight 4 that we observed pay high dividends on the client that I'm working with the client that I'm working with. One is around good governance. And what that means is focusing on lightweight governance models that won't prohibit developers and engineering organizations from delivering products to production, but a standards-based approach, and having the engineering teams, although being very diverse and disparate, having base standards that they can start from, right? Everyone is on board with using a particular database infrastructure. And then on top of that, what are the database patterns? What are our access patterns? What are our ways of interacting with that database? And then standardizing that. When new teams and new services start up, new domains are explored, we've got those base sets of standards that we can look to. And then adding on top of that, a lightweight governance model allows us to quickly figure out if other teams are introducing new technical debt that we want to eliminate, or just eliminating it all together by adding in those best practices that we've already identified. The other piece is creating opportunities for collaboration and review. The reason why that is important is that what we've noticed in some of the earlier startups that are moving from areas like phase 1 and phase 2 to phase 3 is that as they're adding in new team members and rapidly expanding these engineering teams, the architecture falls by the wayside. Not necessarily from it becoming decaying or stagnating, but just the amount of information that gets shared about ways of working and what services are being done, what services are being worked on, and the best practices that are being embedded in there. And one way to spread that knowledge and to eliminate technical debt is by creating these opportunities for collaboration. Team A now gets to work with Team B and find out what those ways of working looks like and what things that they are doing on certain projects and certain domains versus other ones. Establishing quality standards and SLAs. Very, very important, super important to establish those quality standards and SLAs. One reason why is that it provides consistency across all of the different services. But the other one is that no team or no service or no domain gets left behind. We've got a baseline, we have a baseline for what those standards are, and then we can quickly identify and eliminate the technical debt areas that are decreasing our ability to hit those quality standard numbers. So if we see a code review or a code quality number lagging, that's an indicator that we need to address that technical debt issue, eliminate it, and then make sure that we are improving our quality standards in that area. SLA is the same thing. If we're seeing latency issues around our SLAs, or if we have other SLAs, and even fitness functions that we are embedding into our CI/CD pipelines, that gives us an early indicator that we're starting to see some issues around that area. And again, I mentioned fitness functions. As we are evolving the architecture, we're constantly experimenting. We're doing all of these things to enable hypergrowth within the scale-up organization. We need to have some sort of baseline, and fitness functions provide that the perfect opportunity for that baseline so that we don't deviate too far away from the goals of the overall architecture. We're able to evolve, and we're able to rapidly expand and provide these production features for end users, but we're not moving and drifting too far away from the pieces and the architectural goals that we have in mind. So with that being said, we're going to talk about architectural scale-up issues, and I'm certain that people are trying to figure out what is this weird car picture that is here. I was recently reading a very old article from Bloomberg about this new car culture that is in Saudi Arabia right now. Well, not right now, it was a few years ago. However, they were talking about this change in car culture where initially a lot of young people were doing a lot of drifting. I'm pretty certain that Fast and the Furious Tokyo Drift may have just come out, which is a extremely dated reference. But there was a lot of drifting and a lot of car culture that was constantly evolving. And they moved from doing kind of overall drifting to this new way of interacting with the cars, tilting the cars, which they would tilt and drive on one or two wheels and then drive for miles if they could. And so there was this new addition where enthusiasts within that culture created this subculture where they would try and actually change the tires of the car while it was tilting. So the Bloomberg article talks about how this change in the culture created this new way of potentially trying to change the tires of a car while it was still in motion. At my client, we have been constantly attempting to change the car's tires while the car was in motion. And this is an area where they want to continue making investments in the core engineering capabilities and products. That's keeping the car moving. But they also want to deliver new cool features and experiment rapidly and evolve, and that's changing the tires at the same time. So if we attempted to change the car's tires while the car was still moving, what this tilting strategy would be an effective and fine strategy, right? There's a picture there of folks changing the tires on the car while it's still moving. However, this is still very limiting for our engineering organizations and for some of our scale-up clients because they are attempting to change all of the tires on the car at the same time, which would be an extremely daunting task and would require a high amount of increased coordination, heavy planning, lots of technical and engineering work, and luck. So we normally see these types of things when we are dealing with these scale-up organizations. And the outcomes of those things, trying to change the tires while the car is still moving, is generally seen when new applications and new products experiences outages due to spikes in demand or due to just poor planning around scalability and around some of these new product launches. So that's one particular type of problem, but there are many types of problems with these scale-up architectures. And the common problems, we've addressed those or we've expressed those as bottlenecks associated with the architecture. So generally, the types of things that we've observed and we've seen have been overcomplicated distributed architectures. Decreased developer productivity, right? Not being able to get products out into production is a lagging indicator of decreased developer productivity. Lack of observability and monitoring, poor system performance, lack of resiliency, difficulty in integrating legacy or third-party technologies, slow product delivery to customers, low quality code, high mean time to repair, and then accumulation of technical debt throughout the entire application. Now, we've mentioned technical debt quite a few times, and what we want to talk about before we actually start diving deep into some of these architectural patterns is the fact that technical debt is not always bad. With our client, we've been seeing where shortcuts and adding in technical debt into the architecture actually can help them deliver solutions faster to their customer. The key is making sure that technical debt is appropriate. So in 2009, Martin Fowler wrote an article about the technical debt quadrant. And there is this idea of quick and dirty solutions that could technically fall under any of the sales that are in the quadrant. The interesting thing is that what we've noticed with some of our scale-up clients and startup clients are that quick and dirty solutions are sometimes and almost always best, especially while we're in those early phases, phases 1 and 2, where we're doing a lot of quick experimentation, where we're just trying to get as much knowledge from our customers so that we know, oh, we don't need to move in this direction, but we need to move in these other directions. But what we've also noticed is that as we are starting to deal with more clients in phases 3 and 4, that those quick and dirty solutions are also sometimes effective there. And in the technical debt quadrant that Martin talked about, the key is making sure that we maximize our prudent and deliberate technical debt that we're undertaking and not moving into areas where we're having more reckless and inadvertent technical debt. So an example of maximizing deliberate and prudent technical debt would be adding features directly into a monolithic application temporarily to use existing features and delivery infrastructure instead of building all new APIs and building an all new CI/CD pipeline. That helps us to deliver those production features to our end users as quickly as possible because we're using existing infrastructure and existing features, but we know that we're doing this temporarily. And as a part of the plan of delivering those features, we've got the upfront experimentation defined, but then we also have a plan on what the actual delivery of that feature looks like in a more productionized environment. Another example on the data side would be utilizing views within an already existing database instead of making a completely new database for a particular microservice. That allows us to encapsulate and to create what the view and what the data would look like for that microservice while using all of the existing database infrastructure that we have. Right? We're able to provide the service, provide the product to end users as quickly as possible, but then we know that we can extract those views out, create net new tables, create net new database infrastructure once we've got the data based on that experimentation, right? We know that the client or the end users will want that product, and then we can start taking it to a more productionized environment. So these are all areas of technical debt, but as long as we have awareness and our awareness about what we're doing is high enough within the architecture, we're able to understand the consequences and deal with any impact, right? Making sure that we minimize the blast radius of technical debt and how it affects the architecture. So we've done a lot of setup So we're going to talk about some of these architectural patterns. We're going to talk about 3 architectural patterns that we've noticed, and then we're going to talk about 3 anti-patterns that we also saw as we go through the deck here. So Legos. I was recently in Denmark, in Copenhagen, and I had the opportunity to see the new Lego HQ. They have this new headquarters and campus that's there. And as I was going through a small little tour, I noticed that with the Legos that they had there, there were these building blocks that they would have. And everyone thinks about Legos from an individual building block standpoint, that they're taking these individual components and they're building something, right? They might be building, a replica of the Eiffel Tower with Legos, or they might be building the USS Enterprise or something like that. But they're always starting with the individual building blocks. And a lot of our startup clients also think about the individual building blocks as they're starting to build these new systems out. They're thinking about the individual Lego blocks and not necessarily what they're building. A lot of times what we've seen as customers and clients are moving from phase 1 and phase 2 is that they have this very large monolithic system, and their immediate thought process when they bring in some additional engineering expertise is, let's use that to decouple the architecture and go from a monolith to a microservices-based architecture. That's definitely going to solve all of our problems, and that's going to be the thing that helps us to start experiencing and maximizing this hypergrowth phase. But what we've seen is that idea, while admirable, generally is a common anti-pattern, actually, and that we should be looking at more strategic decoupling and a long-term vision about what that decoupling looks like. A lot of teams aren't necessarily ready and don't have the infrastructure and the organizational constructs to go from a monolith to a microservices-based architecture overnight. So thinking about and starting with the biggest piece that we have and decoupling it in a strategic way using all of the tools that are in the toolbox is a common pattern that we've been observing and seeing be effective when dealing with scale-ups, right? Actually starting from the monolith and seeing how that scale and those scaling and performance issues actually drive us to a strategic decoupling, right? So the reason why starting from the monolith actually makes sense is because a lot of times with the monolith, the bounded contexts actually already exist. We just have to do the work to find them. They're either already defined or they're partially defined. It's actually easier to break off into microservices. And then we can take a more strategic route. We can break off things that are more prudent, that provide the most value to our customers. Breaking off things like a new user profile service might actually provide more value to a customer because they're interacting with that more heavily than they are with another part of the system. And decoupling that and then addressing the scaling and performance issues that might be causing for the entirety of the system would provide more value upfront than just having a generic strategy and just breaking things off without having an actual strategic decoupling strategy. So you might ask, what does this actually look like in an architecture? And it could look like something like this, where we have an application UI and a very large monolith that has a bunch of different services or APIs embedded with them, and it's talking to an individual database. And we may say, listen, we're not actually going to do a full-scale microservices architecture here. We're going to do a strategic decoupling. We're going to look at individual groups of services, and we're going to break those services apart. And we're not even going to actually touch the database for this initial strategic decoupling. We're going to start finding what the interaction patterns are, what are the communication protocols that we need to utilize, and then we're going to start decoupling individual services from that, or groups of services, or groups of APIs from there. We're going to do that in place. So where we're talking about, we might not change the language or the underlying infrastructure at first. What we're actually doing is just finding those strategic decoupling points and then finding out what the interaction patterns are. So going from the monolith over to what looks like a microservices-based architecture, but isn't really there, but we can still do and get some of the benefits, right? We can still deploy independently. We can still scale independently. We can do all of these different things that we would normally be able to do with the microservices, a true microservices-based architecture, while keeping the evolvability and actually moving down the road to get us there. So then another thing that we've noticed in working with some of the digital scale-up accounts, and one thing that I've noticed is making sure that we optimize messages and events. Again, much like the microservices-based architecture, it feels like everyone wants to move directly to an event-driven architecture, right? It's the thing that gets us kind of like the best bang for the buck immediately, or that's what we tell ourselves, and those are the things that we think. And while, again, event-driven architectures are very prudent, much needed, when we're dealing with a scale-up, when we're dealing with an organization that might have some legacy technical debt there, and they're really trying to experience that hypergrowth, sometimes we have to ask ourselves, are some of these complex messaging and event structures actually needed to help enable hypergrowth? We will generally default to things like Kafka, to event-based architectures, right at the beginning of our architectural discovery, or an architecture that we are showing to a customer. We'll say, look, we're gonna use Kafka, we're gonna do all of these event-driven and event-based architectures, we're gonna do our event storming exercises, we're gonna find all of these different things that are happening. When it may be more prudent upfront, or as we're experiencing hypergrowth, to default to more simple message queues when they may be needed, right? So the question kind of comes in, is it easier to evolve an architecture that looks like this, which is kind of like this ball of yarn where there's lots of different complicated messaging structures and events that are happening? Or in the beginning, is it easier to deliver features and evolve the architecture from something that looks like this, where we just know that there are two point-to-point communications between the services that are happening. We know what those communications are. And that provides us the ability to kind of build use this as an architectural foundation and build products and services on top of this architectural foundation. And with that, it may be even simpler to defer some of those architectural decisions until the very last moment, right? For us to default to using more simpler protocols for interoperability, default to things like REST and gRPC to start, and not necessarily build a custom binary format to send messages over, right? That might be able to optimize us for performance, but is that actually going to optimize our ability to actually deliver new product features, right? If everyone has to rebuild this custom binary format, is that actually something that's going to help us maximize delivery for customers? Another thing with optimizing messages and events is to default to standards over customization. One example from another digital scale-up that we've seen in the community was the idea of creating a custom format to send pricing information to third-party integration partners. And so that means that all of the third-party integration partners now have to learn this new custom format, even if it's based on an underlying known protocol like CSV or TSV or something like that. It's a net new custom format that they have to learn, build parsers for, and kind of understand. And so that customer had delivered that product, and the integration partner started using it. And one integration partner came to this particular scale up and said, hey, do you know that there's already an existing standard that we could have used that would have allowed us to have already delivered some of these features for pricing information to end users 6 months earlier? And that's why it's always, in most instances, better to default to some sort of standard messaging protocol or standard instead of trying to reinvent the wheel. So one that increases interoperability and increases the ability for partners or for other services to integrate with a main product that might be delivering high value and high in capabilities to your users. So the last pattern that we've been noticing is around data movement. And much like black holes, that's why the picture's there, data is like a black hole within the architecture. Data has gravity within the architecture, right? We generally aren't just sending services, or our services aren't just sending kind of messages to things without having a database or something there that data is driving what we're doing and why we're doing it. That means that those services are usually moving data, and data is usually moving within the architecture, right? From one database to another, from one service to another, from one message channel to another, from one service to our end users. So because data has gravity and data has weight within the architecture, the one thing that we've noticed with some of our scale up and startup clients is that they don't take that gravity into account. A lot of times, and we'll actually talk about this a little bit more in depth when we start talking about one of the anti-patterns around data. But the thing that we want to highlight here is that because data has gravity and data is moving, we need to build our architectures and optimize our architectures for that data movement, right? Many times, especially when we start talking about movement to microservice-based architectures and these event-driven architectures, the big data movement characteristics that we're looking for is this idea about, is this data real time and it needs to move more rapidly, or is it batched? Can it move slower? Can it move in a much more consistent manner? Are there all of these different other architectural underpinnings that we need to identify and realize that's there? The pattern here is making sure that we design and account for that data movement and understand and realize about the gravity and weight that data has. A lot of times we build microservices and we think about the domain, we think about the business context, but we don't think about the movement of data across these different services and across the different domains. So the architectural anti-patterns that we have here. Again, there's going to just be 3. They will coincide a little bit with the architectural patterns, because what we saw was the want to move towards these architectural anti-patterns more so than the want to move toward the actual patterns that we had. So one of the architectural anti-patterns is this idea of early microservices, right? Wanting to have the default position be, we've got to build this microservices architecture, right? Everyone wants to use the cool technology. Everyone wants to introduce the cool architecture. And while we know that microservice architectures allows for improved team autonomy, the developers and engineers get to pick their own languages, pick their own tool sets, optimize things for the business context and the domain that we're looking at, right? Python is an extremely powerful data analytics language. If we're doing data analytics, we can add Python into that data analytics domain, into that microservice, so that we can maximize those things. But what we've noticed is that, especially for teams that are experiencing that hypergrowth, that the barrier for entry is way too high sometimes, and the complexity is way too high for that to be the default position. And as we talked about in the pattern, that it's sometimes easier to start with the monolith, understanding the domain, and then decoupling that, especially when growing the business is the priority. So again, there's the increase in dependencies, the increase in technical coordination. A lot of times those scale-ups and those startup organizations are not able to increase their team size as rapidly as they would want to. So team size becomes a constraint. And then the infrastructure effort for providing all of the infrastructure to deliver those microservices also becomes a constraint. So the one versus the many, one being easier to manage, many sometimes being harder to manage. The other anti-pattern is around the late monolith, the monolith that kind of stays around too long. It's really easy. We know this, right? We've got this large, super big Node.js application that has hundreds of API calls. We know all of them. We've got our Swagger documentation that's created automatically. But as you add new functionality to the monolith, or to even net new services that are around that monolith, the monolith becomes more and more of a bottleneck. The other new services are smaller or more nimble. We can deliver those things more quickly. But that technical debt, as it becomes more later and later into that phase 3, even moving into phase 4, the technical debt in the monolith starts mounting. CI/CD pipelines that are older and less mature, build times that become long. One specific example is around ineffective use of Docker containers. Right? We had a Docker container where there was this huge build times where the Docker container had to pull down 2 or 3 gigabytes of data every time that happened. And because of that, plus package dependencies, build times could be over 20 minutes. And while that monolith is a slow hill to climb, it decreases developer effectiveness and makes all of those deliveries of production super slow. So then the last anti-pattern is around data velocity. And data velocity, what we've seen in the architectures is much like driving a car. There's some limitations in how quickly we can deliver data to our customers and how fast we can drive in a car. You're limited based on all of these different things when you're driving a car. Road conditions, the big one is the speed limit. And you're also limited by how fast your car can go. So within an architecture where you're seeing data moving, you're also limited by similar conditions. Your speed limit is really like the conditions in which you need the data, right? Is this real-time data that we need immediately, transactional data, or is it batch data, right? And understanding what the differences between those two things are really important because that allows you to optimize the architecture for those things. So treating those things the same and not understanding data velocity is the anti-pattern, right? I'm just gonna store data in a database and then we'll pull it out with some ETL packages and then we'll just store it in this other data store, right? But you're not optimizing the architecture to optimize your real-time data versus your batch data. So you can't break the speed limit unless you have a higher one. Like if you're in Montana, there's no speed limit at all. But a lot of times organizations will build in data velocity and need a Montana, but be in a school zone. Or the opposite will happen. They will have the ability to be in Montana, but actually need to be in a school zone, right? So being able to understand the difference between real-time data and batch, better architectures are generally driven by that gravity of data, where the data is, and not by what's being architected in the beginning. So I want to talk about, to conclude, measuring the improvement. What are some of the things that we can do to measure the improvement? And I'm going to talk about three things in particular. There's a bunch of different texts there, but there's 3 big things that we want to talk about. One is valuing lead time, right? Are these architectural improvements increasing our lead time, right? Is it increasing our ability to deliver new features, new products to our end users faster, right? And there's a bunch of different metrics that we could collect with the client that I support. We looked at lead time and cycle time in particular as one metric that was a leading indicator as to whether or not certain architectural changes were helping us. So we definitely looked at that. The other piece is around impact to the end user, right? We're building these new products, we're making these architectural changes, but how are they actually impacting the user? Is it net new products that we're providing, or is it increasing performance and scalability, right? A bunch of users get onto the new application or new product because we've just delivered that, and now everyone can't use it. But we've made an architectural change that allows everyone to use it. So that's things like customer onboarding time, latency within the system. Those are metrics that we should be collecting and able to report on to understand what the actual impact to the user is. The last one is actually something that we've just started to take a look at on the account, and that's actually engineering satisfaction within the organization. Are these architectural changes that we're making actually increasing developer effectiveness? Is it increasing the engineering satisfaction that's on that's within the organization? Is it improving the engineer's ability to deliver software, products, and features to the customers? So one of the things that we've just introduced is an engineering survey where we are asking specific questions about architectural changes that have happened within the past 6 months and how those things may or may not have improved developer effectiveness and engineering satisfaction on the account. So we've gone through the entire journey here. We've identified what the scale-ups are, why we were even looking at architectural changes on the scale-up accounts that we have, some of the observations, things that have been successful, the patterns, things that have been not so successful, the anti-patterns, and how do we measure improvement. So I just want to say thank you to everyone, and I hope you enjoyed my talk, and hopefully you all get something out of it. And if there's any deep sea fishing spots, please reach out to me on Twitter. Thank you.